This is a story about a young boy who had a dream of becoming a filmmaker. To make his dream come true, he applied to study film at the University of Illinois. His father, however, objected to this decision, pointing out the fickle nature of the entertainment industry. He wished for his son to become a professor, saying every year 50,000 performers compete for 200 available roles on Broadway. Unwilling to give up on his dream, he went against his father's wish and boarded a flight towards the United States. Because of this, their relationship soured, and in the years to come, they would hardly speak to each other. Time passed, and having graduated from film school, the young man was ready to make a name for himself. However, he soon came to realize that what his father had said about the harsh reality of working in film had been true. Over the next 6 years, he struggled, taking on menial jobs and doing what he could to further his career. For the most part, to no avail. Once he tried to pitch a screenplay to more than 30 different production companies, but each time, despite all his efforts, he was rejected. There is an old Chinese saying that at 30, one stands firm. The young man, however, having turned 30, found himself far from firmly grounded in life. He had gotten married to a college classmate, and the two had started a family. But the young couple struggled financially. His inability to support and provide for his family weighed heavily on the young man, and he was plagued by constant feelings of guilt and doubt on whether or not to give up on his dream. His wife worked for a small pharmaceutical research laboratory, and with her modest income, supported the family. In turn, the young man took on all the housework, cooking, cleaning, and looking after their son. On top of that, he would read and write scripts, as well as review films. To his in-laws, this kind of life seemed undignified for a man his age, so they would send their daughter money, hoping the young man would open up a Chinese restaurant. But his wife refused to take their money. When he found out about this, he stayed up for many nights, contemplating his life, and he finally came to the conclusion that this dream of his was not meant to be. In the hopes of finding employment, he enrolled in a computer course at a nearby community college, a decision that dampened his mood in the weeks to come. His wife noticed her husband's unusual demeanor, and in time came to learn the reason for the changes in his behavior. One morning, upon getting ready to leave for work, she spoke words of encouragement that her husband so desperately needed to hear. "Don't forget your dream," she said. "There are so many people already working with computers. They don't need you to do that. If you want that golden statue, you have to commit to your dream." As soon as his wife left, the young man grabbed his class schedule and tore it to pieces. His dream, which had slowly been drowned by the demands of life, was beginning to come back to life, thanks to his wife's touching words. Ang Lee spent the next few years pitching ideas to Hollywood studios, but none of them got accepted. He endured one frustrating setback after the other, until finally, one day, he simply decided to shoot his own films, with minimal funding if need be. Before long, his work gained recognition within the industry, and soon enough, he began to win international awards for some of his films. When he entered a screenplay contest in his native Taiwan, using 2 of his screenplays, he won both first and second place. In 1999, he was asked to to direct a movie based on ancient Chinese martial arts. Excited about this opportunity, he assembled a team from Taiwan, Hong Kong, Malaysia, China, as well as the US. In 2000, Crouching Tiger, Hidden Dragon became the highest grossing foreign language film in many countries, including the US, and it won an Academy Award for Best Foreign Language Film. In 2005, he directed Brokeback Mountain, a romantic drama about two cowboys who fall in love. The movie was critically acclaimed and won Ang Lee his first Academy Award for Best Director, a feat he repeated in 2012 when he directed Life of Pi. Ang Lee's story is one of courage, self-belief, and perseverance. You see, in life, in your life, nothing worth having ever comes easily. We all must accept failure and setbacks as part of our journey. But giving in to defeat does not mean giving up on one's dream. Show courage in times of despair. Believe in your dreams, even if no one else will. Persevere in the face of adversity, and you too can realize your dream. This is Dare to Do Motivation.
Well, uh, already in the last class, I have shown this, but that class, many of you were absent. So from starting onwards, we'll have introduction to Wire EDM, and then how does it work, and all these things will be explained by him. And immediately after that, we are going to have a look on all the process parameters or some detailed parameters which are very important for your exam, and that I'll be explaining you. Okay, just have a look on it.
President of Reliable EDM, has a wealth of machining experience. Having worked as a machinist, tool and die maker, foreman, tool designer, and operations manager, Carl now shares with you from his wealth of experience.
Introduction to Wire EDM. Wire EDM has revolutionized machining. And right over here, this is a Wire EDM, and also the machines behind us are Wire EDM machines. And we cut all kinds of shapes with Wire EDM. This is a spool of wire that we use. It's brass, and you can envision this here, wire. It's like a precision bandsaw, and we can cut up to 45 degrees. Anything that is electrically conductive, even tungsten carbide, hastelloy, Inconel, all kinds of exotic metals, if it conducts electricity.
Note down a few things what he has said. Like this one is spool. Okay, so generally in die sinking medium we use some tool. Okay, but here this spool, which is consisting of some wire. Okay, which material it is made of, everything will be explained. So this is called spool. Spool means it is winding. Means the wire is winded in that. Okay, we are going to fit it. Everything he will show in his videos. Okay. So today's class I'll be displaying these videos only so that you will get some idea, and next class I'll be explaining about other things. Okay, so this only works as the electrode in case of wire cut EDM. Okay, and you must remember that once again, like die sinking EDM, anything or any material which is electrically conductive can be machined using this technique. Okay, irrespective of its hardness. Like what he has said, he has discussed about hastelloy. Hastelloy is the alloy. Okay, Inconel. Okay, that is also one alloy. uh, yes, spool is not tool. Okay, spool is not tool. Wire is the tool in this case. Spool is something where the wire is winded. Okay, you might have noticed like electrical wires. So big spools, those things are called spool. I will tell you. You can see this one, this cabinet kind of thing. This is called spool, where this wire is mounted. Okay, like if you go for finding cello tape or black tape or this kind of things, Okay, so that will also be winded. No, so similarly here it will wind. So this complete thing is called as spool. Okay, so he said, note down. He said that Inconel, Hastalloy, these are some super alloys. Okay, very hard to cut material and very strong. So those materials also, even carbides can be cut using wire cut EDM. Okay, so just note down the points what he is explaining.
We can cut with wire, and wire comes into 1,000s up to 14,000s. We go generally about up to 4,000s, and with accuracies up to plus or minus 1/10 of a thousand. Now, an average hair thickness is 2.5 thousandths, and if you can slice that hair 25 times, that's how close we can cut with wire EDM. This is another wire EDM machine, and here you can see the wire coming in from the back of the machine. It goes up in these rollers.
I said in last class also that here these things are maintained, or these pulleys are used in order to maintain some wire tension. So you see the wire is coming from this end, okay, and through all these mechanisms it is going in this direction, and here it is cutting this workpiece. He will show it. Okay, he will be showing it. So this wire tension is another one parameter, and because of that only this kind of mechanism is built. Okay.
And it comes down into here, and then it goes through the diamond guide. And here's a part in the machine where we're cutting out the keyway.
He said here there is something called diamond guide. So anyhow, I'll be explaining about diamond guide, and even he also will be explaining it. You just have a look on it.
Keyway in here that was already cut out. And this machine also, and most of the machines are that way, this is an automatic wire feed system. And many of our machines do have this. And this will automatically cut the wire, and the wire goes back and gets chopped up, and then the machine moves over and it will automatically rethread. And one of the advantages of this automatic wire feed is that we can have the cavity here filled with parts and would automatically rethread at each section wherever we program this machine. This is another one of our EDM machines here, and this is one of our large ones, to give you a little idea of the size of it. And this machine can cut up to 26 inches submersed. This machine, from here to here, is 26 inches deep, and it's filled with deionized water. It's submersible. And we have a part over here that's for the oil field, and we're cutting a taper in here, and it's a circle on the bottom, and like a little shape cut out over here, and this is the shaft. I like to talk about our showpiece that we have over here. And this is an eagle, as you can see right over here, and here's Texas. And this would be impossible to machine with conventional machining. Just look at the detail on this eagle and the arrows over here. And then look at the lettering here, reliable EDM. Notice the thin lines that we cut out. And remember, wire EDM is like a precision bandsaw. Now look at Texas down over here. And there you see the R that we cut out. We left it on there. And then our website. It's all done with wire EDM. I have in my hand a test specimen that we're going to put into this EDM machine to give you an example of how wire EDM cuts. You're going to see the sparking taking place. But there's a lot more to this. We're going to go into details in other videos, how wire EDM works, and also the amazing capabilities of this system. Now we have the test piece mounted in the machine over here. But I want to stress, this is not the normal way we do our cutting. I have in my hand a flush cup. Usually what we want is the flush cup riding along the bottom. This makes it a much more efficient operation. And also on the top. We're just doing this so you can see the sparking taking place. Now we're filling the tank with water. This is the ionized fluid. Later on, we'll explain more about what this water, how it works. The wire has to be surrounded by water for it to cut. The water acts like a resistor. Now we see the spark erosion taking place, and it's cutting. Sparks jump from the wire to the workpiece, and there's always a gap. Later on, we'll go in much more detail what actually happens within that cavity. It is spark erosion. the sparks are eroding the metal particles. And then the filter system removes the eroded particles. Now I'm going to turn the flush on, and this is what we would normally have, but then you can't see the sparking so good. Look at the sparks now, it's cutting into that edge. There you can see the full length of that wire now cutting into that edge. We just took this test piece out of the machine, and you saw the spark erosion taking place. Now I want you to look at this scene where we're going to be skim cutting this entire piece. One of the questions is with the wire, what happens to it? How many times do you use it? We only use the wire one time. And at the back of the machine, we chop up the wire into tiny little pieces. And so we have these choppers that are in the back there, and then we sell it for scrap. This is not gold. This is just wire that has been chopped up into fine little pieces. My son, who's a mechanical engineer, and I have written this book, The Complete EDM Handbook. It's used in trade schools and colleges as a textbook.
In this video,
and it's free on our website. And there's
EDM and how it is working. So that thing now in this video you are going to understand. Okay.
President of Reliable EDM has a wealth of machining tool of experience.
Now let's look, how does Wire EDM work? Wire EDM is like any other machining process. However, it uses a unique method of cutting metal that is electrically conductive. We start over here with a new wire electrode. There's a pulley over here and it comes through, and here's an upper diamond guide. Then the wire goes through this here flush port. Now they're usually closer together, but this is just a drawing. And notice there's an arrow over here, and let's go to the bottom over here. And otherwise, here we see pressurized, filtered, and cooled dielectric fluid. And I'm going to explain a little more about what that does. And there's a pump then that pumps this water, and notice over here it goes to the upper guide and also through the lower guide. And notice here there's a lower diamond guide over here. And this is the workpiece. So here's the wire going through here, and then the bottom roller over here, the wire goes out. This is the used wire electrode. As I demonstrated in the previous videos, this goes out here, and on the new machines it gets chopped up. Now let's go and actually look.
Now here he has said, like what he has explained, that here we are going to have the dielectric. Okay, so that is pumped through this this chamber, okay, or this channel. Now here we are going to keep the workpiece, right? So the workpiece, bottom side of it and top side of the workpiece, okay. So both sides will have some diamond guide. He has discussed about diamond guide. So this diamond guide, what is the function of it? It will keep the wire in a straight direction or in the same direction, okay. So it will not allow the wire to be vibrated or to get vibrated, as well as it will also not get deviated from its path, okay. And here we have got one pulley, as you have seen, and it is coming out. So all the time it is not necessary that the wire will be chopped up, okay, or it will be like some dust which he has shown, okay. It is not possible all the time. So here in this EDM, it is getting chopped up, because so that we can go for further use, like we can melt it and we can manufacture it. But all the time it will not happen. So that time we have to gather those scraps and we have to send it to some other machines. We have to chop it, okay.
And on the new machines, it gets chopped up. Now let's go and actually look inside where the workpiece and the wire is and what happens. And that's in this drawing over here. This is the wire electrode, this black over here. The yellow is the workpiece. The magenta is deionized dielectric fluid. surrounds wire electrode and workpiece. Now this is important. When we get over here, we're going to explain what happens with the dielectric fluid over here. Now the voltage and the amperage control the spark between the wire electrode and the workpiece. So there's controlled sparking taking place over here. And here's the EDM power supply, the volts and the amps, that's going to create later on in this drawing a spark. Now let's see what happens when the sparking takes place. Here again is the wire electrode. This is the dielectric fluid. This is the workpiece. Dielectric fluid acts as a resistor until enough voltage is applied. Dielectric fluid is basically fluid that doesn't conduct electricity under normal circumstances. Now the fluid that we use in the EDM machines is water. Normal water has too much minerals in it. And so what we have in the machines are resin tanks to control the conductivity of the water. Remember, pure water does not conduct electricity. It's the minerals that they get from the ground that goes into the water and causes it to be too conductive. So these resin tanks then control the conductivity of the water. Between the electrode and the workpiece, there's this here.
Did you understand what is this? This is nothing but the cross-sectional view of the wire which we are using. Anyhow, I'll also tell you like what is generally the diameter of the wire which we use. Okay, all these things in the latter part I will be discussing. Okay, just have a look at it.
Water, this dielectric fluid that acts as a resistor. Now remember, this brass wire and this workpiece, there always has to be a gap. If this wire touches the workpiece, we have a short circuit. So the secret of this wire EDM machine is a servo mechanism that always maintains a gap between the workpiece and the wire electrode. So whether we're cutting straight or up to 45 degrees taper, there is always this gap that is present. Dielectric fluid acts as a resistor until enough voltage is applied. Then the fluid ionizes and sparks occur between the wire electrode and the workpiece. So here we see the sparks occurring between the wire and the workpiece. An interesting thing happens during the sparking process. There's only one spark at a time. Now this drawing over here, we see multiple sparks at the same time over here. But it's basically one spark at a time, but multitude, thousands of sparks per second. Then it says here, sparks precisely melt and vaporize the material. Now notice this word precisely. I just want to give you a little idea. I'll use this as an example. I have an item here that we cut out, it's a round circle. Let's make believe that this diameter is a human hair. The average thickness of a human hair is 2.5 thousandths. And I'll write this on the chalkboard. It's 0.0025. So if this diameter is a human hair, there are 25 1/10ths in this human hair. So we can cut then plus or minus 1/25th of the thickness of a human hair. In the next video, we're going to continue to examine how wire EDM works. We'll see a regular cutting operation, and then we'll examine a skim cutting operation. Plus, there's lots more that you'll be examining.
Located in the heart of the high-tech.
Okay, so next part of this we'll be checking. Okay.
President of Reliable EDM. Die maker with you.
Of wire EDM cutting. The first example we have is this Texas Tech symbol that we're making for their football team. And what we have in the machine is this big T, and we're making that a cutout in there so the small T will fit into it. Now there we have the nozzles up in the air. This is not the ideal cutting condition. The ideal cutting condition for wire EDM is the top nozzle and the bottom nozzle to be on the workpiece. And the reason we do this is so they have maximum flushing pressure because we have to get rid of the eroded particles. However, If we showed you this example, you wouldn't see any sparking. So what we have then is the nozzle up in the air, and the first example is with no flushing, and the second example is when we put on the flushing. The second example we have is this reliable EDM showpiece. And here you can see the wire electrode along the whole surface and sparking occurring. Now we're doing the first one with no water in the tank, just the water rolling along the surface. This again is not the ideal method. This is a machine that is totally submersible. The second cut, you'll see the ideal way to be skim cutting, where we have this filled with water, and there it is skim cutting. But you don't get as good picture in the second one as in the first one. So that's why we have shown you both ways of how we're doing our skim cutting. There are rapid electrical impulses between the wire electrode and the workpiece. Now let's examine what happens between the on and off times of this here sparking process. When the sparking process is complete, the melted workpiece material is cooled and pressurized dielectric fluid removes the eroded particles. A filter removes the EDM chips. Now you were creating chips over here. So now you have this, going back again to this drawing over here.
Here just I want to explain something. So you might have already understood that this yellow part is workpiece and this is nothing but the electrode or the wire, right? So this shape has generated on the wire surface, and you might have seen that this kind of shape got generated on the workpiece. Actually, in this case, the wire is coming from left to right. Okay, so from here, already this pink portion, this is cut out, right? Already this pink portion already cut. So what are these? These are the cut part of this wire. That means not only the workpiece will get eroded, also there will be erosion from the surface of the wire. That means electrode. Okay. And this side is going, it is having some feed in this direction. That's why you can see like here also some more amount of material got removed from the workpiece. Okay.
Here we have pressurized dielectric fluid being pumped through these flush cups to, as you see over here, and the pressurized fluid removes the EDM chips. Here's another drawing of this here path of wire electrode generated by CNC automated computer system.
Now here I would like to say that as the controlled motion, already I have discussed about servo mechanism. So that has to be installed in all these unconventional machining processes or UCMP tools. Okay, like EDM tool, it may be ECM tool, whatever it is, so that we can achieve controlled feed mechanism or controlled movement of the tool as well as the workpiece, right? So that's the reason why this wire cut EDM also will be controlled. You might have already seen that cut part of the eagle. Okay, it is very difficult or impossible to generate the same sort of profile by using any other machining technique other than wire cut EDM, because that much finishing and that much sharp corners cannot be achieved by any other machining processes. Okay, and that has to be modeled first, and then it has to be converted into some GNN codes, and then only it can give you the controlled motion.
Here's the pressurized fluid on the top and the bottom, which escapes, and the spark erosion causes the material to be eroded. The material removed is cooled by a dielectric fluid, and that's another feature of the dielectric fluid. It cools the material. Remember, if there's too much heat, everything expands and you lose accuracy. So there's a chiller on these machines to keep the temperature of the water at a certain temperature. This is extremely important for accuracy. The gauge of wire ranges from 0.001 thousandths to 0.014 thousandths. In millimeters, it's 0.025 to 0.357 millimeters. In our shop, we generally go down to 4 thousandths thick wire. But we need to remember, when you use these smaller wires, like 4 thousandths or 6 thousandths or 8 thousandths, you cannot put that much electrical current into it. So it's a slower cutting process, and it becomes more expensive. Another thing we need to remember, also, that the wire electrode never contacts the workpiece, that there's always a gap. Now, depending upon the energy of these sparks determines the surface finish of the EDM parts. Now, we can take a rough cut, and you will look and say, well, that looks very good. Now, we can make these sparks very minute, and that's what we call skim cuts. We go over and over again, and we can get practically a mirror finish that way by having these sparks very, very small, very little amount of energy. So these pits are not as large as these. They get smaller and smaller. And you can see that we get practically a mirror finish with wire EDM. I'd like to show you an example of the finish that we get with a rough cut. Now, this is a 40-inch part that I'm pulling out over here. Now, just take a look. I'm going to put a flashlight at the other end so you can take a look at it. We have examined the wire EDM process, how it cuts, how it machines. And remember, wire EDM can cut any electrically conductive material. Even this tube bit has been machined with wire EDM. This is carbide, and it's been silver soldered onto this metal shank. It can cut also hastelloy, inconel, and other exotic materials. Extremely fine finishes of below 15 RMS can be produced with wire EDM. Even in the so-called rough cut that we demonstrated before, this part, we will get an excellent finish. This fine finish is present even when very large parts are cut. In other cutting operations, such as lasers and abrasive water jet, the larger the part, the rougher the finish. The reason for the smooth finish with wire EDM is that the wire electrode goes through the entire part, and spark erosion takes place along the entire wire electrode. For instance, on this part, the wire electrode went through the entire part, not like in laser, which cuts with light, or abrasive water jet, where the abrasives come on the top and then it sort of mushrooms out. And also laser cuts with light, and the light mushrooms out, but not with wire EDM. Wire EDM, the entire electrode goes through, and that's why it can cut so accurately. To learn more about this amazing process of EDM.
Okay, so I hope you people got some idea about wire cut EDM. Okay, so many examples were shown in that video, right? Many examples were also shown. So anyhow, so I feel few ideas you got about wire cut EDM by going to the video, but many other factors which are present or not discussed, okay, or not discussed in that case, okay. So those things we will be discussing. So today I am not going to give you much idea, okay, only some 2-3 minutes are left, okay. So in the next class I'll be explaining everything, like what should be the diameter of the wire which has to be used, which wire material we have to use, okay, or what is the tension rate, etc. So those things I'll be discussing, and what generally is the cost, where which you can find. So maybe in your final year, you people will perform some major project. So while performing the major project, you people may have to, or you people may like to go with this wirecard EDM. Okay, and you might be going for optimization of this process parameter. Okay, so in that case, like you need to purchase this spool. So one spool will cost somewhere around 2,500 to 5,000 also. It depends on how many windings it has with it. And secondly, which wire you are going to purchase, whether you are going for copper, zinc coated copper, or zinc coated brass, or only brass wire. Okay, so what can be the brass materials? So those things in the next class I will be discussing with you. Okay, and another one important factor thing what sir explained in that video is generally the wire. Okay, generally the wire which is used for this machining purpose. Okay, so that should not be reused. Okay, so only one time we are going to use that wire. uh, and so these are the few things, and few more things also I'll be discussing in the next class. Now if anybody has any query or anything to ask, you can ask. If anybody wants to ask anything, you can ask.